As it's the silly season and I'm feeling particularly silly, I thought I'd do a silly season silly video. And just recently I've been fascinated by these little pics, and I've also been fascinated by 8-bit music, square wave music. So I thought, right, I know what I'll do for my silly video. I'll make a little pic, produce some 8-bit music, and what better music than some seasonal music. So here's a square wave. It goes up where it's sort of switched on for a period, and it turns off for a period, and the period, the total cycle, is 1 over the frequency. So for instance, if the frequency was 1000 Hertz, this period would be 1 millisecond, which makes that on time half a millisecond and the off time half a millisecond. And we can calculate that period for various musical notes. And this is what we get. For instance, Jingle Bells has only got these few notes in it, and middle C, 261 Hertz, has got a period of 3.822 milliseconds, and the G has got a period of 2.55 milliseconds. The half cycle time is 1.911 or 1911 microseconds. But this is a 16-bit, this is an 8-bit machine, so doing numbers like that in 8 bits is a bit awkward. So if we divide them by 8 again, we get these numbers, and these will fit in 8 bits. So that's what I've done. So the program's really crude. You set up the delay, which is the half cycle delay, which is the number between 0 and 255, as I showed you before. And you set up the number of cycles that you want, say, to play a minim or a crotchet. So, for instance, in this one, I think we use 80 cycles for note E for a crotchet and 160 cycles for a minim. And to play the note, you turn the output on. This is a digital output pin on the pick. You do a half cycle delay, then you turn the output off and you do a half cycle delay. You decrement the cycles count, and if it hasn't reached 0, you go around the loop again. So you do however many cycles you've programmed in, and then the note stops. And just to make it easy, I've done the timing loop is done in 8 microsecond intervals. Just so that we get the number between 0 and 255 for typical sort of note values. Then to play the tune, we just set up the delay, which for the frequency, set up the number of cycles we want to play, call the note function, set up the next note, which is the frequency, the number of cycles, call it, and that's all it is, just one great big listing like that. Now I know I should lay this out properly, but I already had a pick on a board, which was a previous project. It's got a temperature and a hygrometer sensor there, and a 433 meg transmitter there. And I thought, well, why not just repurpose this instead of doing a new board? So all I have to do is just change the program. I've got the programming lead connected to the thing permanently. So I'm just going to reflash the pic. So we have here a program called MHz ISM.exe. This is running in Linux, but it will run perfectly okay. So we'll double click that. And wait a minute then. We browse to the file that we want, which is the Jingle Bells. I can't flipping see. And then we just click assemble, and that's it, it's assembled. So it's now created jinglebells.hex, and we've now got to load that hex file into the pic. Now I just have to use a little program to burn this hex program into the pic, and the program is called PK2 command, and you've got all these switches to set the voltage and all sorts of other stuff, and there's the file name, jinglebells.hex. So we'll run that and it'll burn that into the pic, and then the thing should just start running. Well, it's running. It's actually playing Jingle Bells, would you believe? But you see, these things are dodgy. Nothing ever goes right, does it? There's all sorts of intermittencies on these little boards. These breadboards are incredibly intermittent. I don't know how anybody ever gets any projects to work on them, but you really have to fiddle with the wires to make them work. Anyway, it's working, as you just saw, and that was my incredibly stupid Christmas project. And now none of the weather stations around here can communicate with each other because I'm spamming them with Jingle Bells on 433.9.